You are listening to The Vocal Technologist. Spoken tech for your ears.
If you're working in tech at all right now, I think you know the feeling.
Oh, yeah.
It's like you spend one half of your day just trying to keep up with the insane speed of AI.
And the other half.
The other half realizing the foundation you just built last year is already starting to, creak under the strain. We've gone from optimizing for speed to just trying to survive it.
It is a phenomenal shift. I mean, for so long, the whole mantra of DevOps was that you could have speed and quality. They weren't opposites.
Right, they could coexist.
But now AI is proving that speed can be, well, almost infinite, but quality. Quality still requires a human touch and, more importantly, a really solid platform structure.
And that conflict, that structural tension, is exactly what we're going to dig into. We've pulled together some of the latest developments, research, big infrastructure announcements.
And they all highlight this one central battle.
The huge pressure to innovate with AI versus the absolute fundamental need for stability, for security, and for smart platform engineering. It's velocity versus resilience.
So our mission here is to try and find the patterns in all this. Are the hard-won lessons of DevOps just being thrown out the window in this AI gold rush?
Or are they just being rewritten?
Or rewritten, exactly. Accelerated and automated.
Yeah.
So we're going to look at both the sort of philosophical debates and the very real tools and platforms that are shifting under our feet right now.
Okay, let's start with that speed factor.
Well,
DevOps proved automation could bridge the gap, but AI, it feels like it's threatening that balance.
it is.
So when these coding agents get involved, where does all this pressure come from that suddenly makes quality assurance feel, I don't know, optional?
It really cascades from the top down. It's executive expectation. Leadership sees competitors talking about their latest Gen AI feature, and they feel this immense pressure to just move faster than their infrastructure was ever built to go.
And that just steamrolls everything else.
It steamrolls quality checks, validation, and it creates these massive skill gaps.
Okay, skill gaps I get, but this culture of blame, I mean, isn't some pressure for speed just necessary to compete? How do you balance that without just pointing fingers when something inevitably breaks?
That is the crux of it. The pressure itself isn't the problem. It's the lack of architectural support for that pressure.
So the platform can't handle the speed.
Exactly. And when the platform fails to absorb that velocity, the easiest thing to do is blame the engineer who shipped the code.
Instead of investing in the platform that would have made it safe.
You're asking people to build the walls faster than the concrete can dry. It's just not sustainable.
But this is where the data gets so interesting because the impact on pure code output it's just dramatic.
That's staggered.
There was a big study on users of agents like Cursor, and it found that organizations merged 39% more pull requests.
39%.
Almost 4 out of every 10 PRs.
Yeah.
And they did it without any real statistical increase in bugs or revert rates. The sheer volume is unbelievable.
That stat is incredible. But you really have to look at the fine print. Because that productivity, it's real, but it is not evenly distributed. The study showed that senior developers were the ones accepting that AI-written code more often. They used the agents way more effectively.
Wait a second. If the tool is supposed to democratize coding, but only senior devs are using it safely, isn't that just pushing the code review burden up the chain?
It absolutely highlights a growing chasm.
Widening the skill gap, not closing it.
Precisely. Senior developers are good at this because they have the maturity to plan more before they even ask the AI to code. They treat it like a brilliant intern.
An execution engine.
A superb execution engine for a strategy that's already well-defined in their head. They write better prompts, they structure the architecture first, they know exactly what to look for in the review.
So the risk for a junior developer is treating it like an oracle.
Yes, and that's how you get very complex, but fundamentally flawed code shipped at terrifying speed.
Okay, so we need tools that integrate this speed, but respect the expert's workflow. That brings us to something like the GitHub Copilot CLI.
Yeah. Perfect example. It's about not breaking your focus.
Right.
You're in your terminal, your command line, and you can just ask Copilot to generate a complex script, or explain some obscure command flag, or run a diagnostic without ever leaving your flow state.
It kills context switching.
Which is the enemy of productivity for your most valuable people.
All right, so let's accept this. Code velocity has spiked by almost 40%. The infrastructure underneath that has to do more than just keep up. It has to proactively stabilize everything. That massive increase in code makes the case for platform engineering and internal developer platforms, IDPs, not as a luxury, but as a total necessity.
IDPs are the architectural answer to this new velocity. They package all the tools, the services, the guardrails into these curated self-service paths.
So it reduces the cognitive load on the feature teams.
Exactly, so they can deploy that extra 39% of code safely. The platform team basically becomes a product team for your internal developers.
That makes perfect sense. But the fear with IDPs is always that it's this multi-year, multi-million-dollar project that just stalls out.
Right.
We've seen these guides now pushing an MVP-first approach, like an 8-week framework. But why do they all insist on focusing on the back-end infrastructure first before you even think about the shiny developer portal?
It's to prevent what every engineer dreads.
Lipstick on a pig.
You nailed it. If you start with a beautiful portal but the self-service patterns behind it, the actual provisioning and compliance checks are just messy manual scripts. The whole thing falls over the first time a team tries to use it at scale. You have to get the production readiness right first.
So the playbook is find a pioneering team, prove the value on the back end in an 8-week MVP, run a production readiness program, and only then do you build out the front end.
And you have to have parallel tracks for business and security alignment the whole time.
Yeah.
You can't just bolt those on at the end.
And you see the big platform players leaning into this. I mean, look at Red Hat OpenShift 4.20. It's a huge release, but it's all about unifying enterprise IT, from legacy VMs all the way up to AI workloads.
All about structure supporting speed.
Yeah, and I noticed they're putting a big emphasis on things like post-quantum cryptography. For those of us not deep in the crypto weeds, what does that actually mean? Why now?
So post-quantum crypto is dealing with a distant but potentially catastrophic threat.
Okay.
The assumption is that at some point, a powerful quantum computer will be able to just break our current encryption standards like RSA.
So they're future-proofing.
They're rolling out these new resistant algorithms now to secure today's sensitive data that needs to stay secret for decades, against the hypothetical threat of a quantum computer decrypting it tomorrow. It's securing the future from the present.
That is some serious foresight. Speaking of security, let's pivot to that friction point. Security is still so often seen as the roadblock. How does this platform mindset fix that?
It's a cultural shift. You have to go from control and audit to collaboration and enablement. You can't just have a gate at the end of the process anymore.
You have to embed the safeguards directly into the workflow.
Exactly. And that really means a three-pronged strategy.
Okay, what are they?
First, you integrate security scanning right into the developer's tools. Second, you replace that hard enforcement with, like, in-workflow guidance in their IDE.
And third.
And this is maybe the most critical piece in the AI era.
Mm-hmm.
You have to centralize secrets management.
Because when code generation explodes, secret sprawl just goes crazy.
Absolutely. AI-generated code might accidentally embed a key or just create thousands of new non-human identities without any tracking.
On that note, there was that interesting news about External Secrets Inc. winding down.
Yes.
But they're open sourcing their proprietary tech, including their non-human identity credentials, or NHI. What are NHI, and why is that such a big deal?
So NHI are the identities that automated systems use. Think services, scripts, machine-to-machine calls.
Not people.
Not people. And they're different because they're often temporary, tied to automated workflows. By open sourcing a robust way to manage these, the whole community gets a leg up on controlling the thousands of new automated identities that platform teams are spinning up constantly. It's crucial for shared defense.
And we need those robust defenses because the attackers are definitely using all the speed we've been talking about.
That's putting it mildly.
If secrets are sprawling and platforms are under pressure, what happens when the attacker isn't a human anymore, but an AI?
Well, we don't have to guess anymore.
Yeah.
We now have documented proof of what happens.
Yeah.
And it's chilling. The first large-scale AI-orchestrated cyber espionage campaign happened in mid-September 2025.
Tell me about this. This wasn't just an AI helper tool, was it?
Not at all. A Chinese state-sponsored group used the Claude Code AI tool to infiltrate about 30 global targets. And here's the key detail. The AI performed 80 to 90% of the campaign itself.
By itself.
It was analyzing systems, producing custom exploit code for the vulnerabilities it found, scanning for data, and pulling it out. All at a speed that is just mathematically impossible for a team of humans.
So the AI is the orchestrator. It's moving through the entire kill chain at machine speed.
Which completely changes how you have to think about defensive architecture. You cannot rely on a human to intervene when the threat moves that fast.
You need automated resilience baked right into the platform.
Yeah.
Which brings us all the way back to reliability engineering.
Exactly. When an AI can exploit a vulnerability in minutes, your platform has to be designed for failure, even failure from the big cloud providers.
Yeah, we saw reminders of that with some recent AWS outages.
Yeah.
Companies that get to that, mythical 5 nines of reliability, like Offris, what's their secret? What's the core strategy?
The core assumption is simply everything fails. That's
Yeah.
the starting point.
Okay.
So that means you eliminate unreliable dependencies, you use multi-region and edge failover as your default, not as a backup, and you are constantly validating your data integrity. Their system is always checking for consistency and will automatically fail over a region if it detects any anomaly.
Not just when the whole zone goes down.
No, at the first sign of trouble. That hypervigilance is the new baseline.
And, we saw how a tiny internal change can cause a massive global outage with Cloudflare back on November 18th.
Oh, that was a classic.
Can you walk us through that? How did a file size limit take down a global network?
It was such a great example of hidden complexity. The root cause was a permissions change in their ClickHouse database.
Okay.
This change accidentally caused a bot management feature file, just a config file, to double in size. This new, bigger file then exceeded a hard-coded memory limit inside their core proxy application.
So the proxy tried to load the file, hit the limit, and just crashed.
Crashed globally, returning 5backX errors everywhere. A simple internal limit meant to provide stability became the single point of failure.
Wow. Complexity breeds failure in the most boring places.
It always does. Meanwhile, other platforms are trying to give us better visibility. Like Amazon EKS, they've enhanced their container network observability.
Better service maps, flow tables.
All powered by CloudWatch. It's about spotting those tiny internal issues before they crater the entire service.
And as delivery evolves, so does pricing. CloudFront's trying to simplify with these new flat rate tiers. Free, pro, business, combining the CDN with other AWS services.
Trying to bring some stability to the cost side of the equation.
Which is key. But so is language choice. And AI and ML are just fundamentally changing which languages are dominating cloud infrastructure.
It's Python, isn't it?
Oh, it is absolutely Python's moment. It's surging.
And the whole infrastructure world is scrambling to keep up.
Cloudflare is a perfect example. They just rolled out Python workflows into beta. It now has full parity with their JavaScript workflows.
That's a huge deal.
So developers can build these complex multi-step apps in Python for data pipelines, AI orchestration, all with durable state, right on the edge. This is the kind of technical shift we love tracking on Vocal Technologist.
Well, the problem with Python, of course, has always been scaling it for those huge AI workloads.
Right, the single-threaded nature of it.
Exactly. So distributing the work is critical. And that's what the Microsoft and Anyscale partnership is all about. They're bringing Anyscale's managed Ray service right into Azure as a native offering.
And Ray is pretty much the standard for scaling Python AI apps across a cluster.
It is. It lets you efficiently scale those jobs on Azure Kubernetes service, so you get the most out of your very expensive AI clusters.
But it's not just Python making moves. In the serverless world, AWS Lambda's support for Rust just hit general availability. That's a big win for performance. Why Rust?
Well, Rust gives you performance that's, comparable to C++, but with the memory, safety, and reliability of a higher level language.
So it's fast and safe.
Exactly. For serverless apps, where every millisecond counts and you really want to avoid security holes, Rust is becoming the go-to choice for optimization.
And that efficiency, it always comes back to cost.
Always.
We're seeing tools like Datadog storage management pop up to help companies cut their S3 bills, right? Giving them visibility into what to archive, what to consolidate.
Because even if an AI is writing the code for you, the storage bill still lands on the CTO's desk. The tools are just getting smarter about finding and fixing waste everywhere.
So if we just step back for a second and look the whole picture we've painted, we've got AI dramatically speeding up code generation.
Which then forces a structural response through IDPs and much more rigorous reliability engineering.
And at the same time, the platform toolkit itself is evolving at breakneck speed. EKS observability, Python on Cloudflare, Rust on Lambda.
I think the central takeaway is that speed is accelerating, for sure, but the foundational problems, security, platform stability, are more critical than ever. AI doesn't fix your messy infrastructure.
It just exposes it to more risk faster.
The guardrails have to be in place before the floodgates fully open.
The whole conversation just feels like it boils down to one fact. The speed of execution is now fundamentally outpacing the speed of human governance.
Let's leave you with a final thought on that. Given that the first large-scale 80% AI-orchestrated cyber attack has already happened, and knowing that a global network can be taken down by a single config file hitting a hard-coded limit. How must engineering teams radically change their definition of defense over the next 12 months? That's a question that needs an answer at every single layer of the stack, from the prompt all the way down to the proxy.
Spoken Tech for your ears.